Good afternoon, everybody. You're all very welcome to this talk as part of Postgraduate Webinar Week with DCU. My name is Martin Kelly. I work with the Postgraduate Recruitment team here at Dublin City University. And I'm delighted to welcome now to present this talk from our School of Electronic Engineering, Dr. Derek Malloy and Dr. Richard Bulger. Guys, if you have any questions throughout the presentations, please do type them into the chat, as Richard has demonstrated with the detailed descriptions there. So if you have any questions, please advise that they'll be addressed at the end of the presentations. I'm going to hand it over to Richard and Derek now. Gents, I'll be off camera if you need me. Enjoy.
Thanks a million. Hopefully you can hear me okay at this stage, yeah?
Yeah, I can see you both. I can hear you at the minute, Derek. Obviously, Richard has his mic muted at the moment, but I can see and hear you perfectly.
So I'm going to start off. Thanks very much for the introduction. I'm going to start off and work through the slides. So just for context, everything that I'm discussing at the start in the introduction applies to both programs. And then I go into program-specific information for the MCTY program, which is the Masters in IoT. And then Richard is going to take over and discuss the MEng in Electronic and Computer Engineering and the majors that are available in that program. So the MSc in Electronic and Computer Technology is the program with a single major in IoT, and then there are different engineering options available within the MEng program. So you should be clear on the distinction by the end of the presentation. So I'm Derek Malloy. I'm a professor in the School of Electronic Engineering, and I'm the chair of that program, and Richard is the chair of the MEng program. So we'll work through that. Both of those. As Martin said, there's the chat window on the right hand side. Please paste any questions in there, and we'll work through them as we get through the presentation. And we'll have time at the end as well if there's any questions to talk through. So DCU, just for those of you who haven't or don't know of DCU, we're a relatively young university. We're in the top 100 young universities worldwide. Now, young in the context of universities is 50 years or younger. So there would be universities that are around for hundreds of years. So we're relatively a young and dynamic university. We're very highly ranked, which I suppose it's one thing to say you're ranked first in Ireland and 19th in the world for graduate employment rate. But when you take into account there are more than 50,000 universities worldwide, being 19th worldwide is quite impressive. It's higher than most of the Ivy League universities in the world, including engineering institutions like MIT, for example. So we're extremely well placed in terms of employability. And that comes from, as you'll see through the programs, the way that we structure our programs to be very much aligned with industry needs and state-of-the-art research as well. So it's very much part of what we do in this master's. We're ranked, typically we rate strongly on lots of different metrics, and including our social and economic impact, where we rate in the top 100 globally, which is again quite a significant achievement given the number of universities that there are. We're also constantly receiving awards, including the University of the Year award for 2021, and we haven't rested on our laurels since then. This is just to show you why, one of the reasons why we have such an engagement with employability and employment, and especially in the engineering space, where, you know, the majors of IoT and all of the majors in image processing and so on, and machine learning are vital to industry. You know, the next generation of industry products. So you'll see here, for example, this is just to give you an idea. And again, if you're from international venue, you don't really know Dublin. Dublin, this is a zoom in on a part of Dublin, and you can see we're here. This is DCU right here in the top corner, and around it you can see many names that you should recognize quite well, from companies like Nokia to IBM to PayPal to, you'll see Google in here, Stripe, huge, massive companies, and even down in the bottom you'll see companies like Storyful, Ericsson's, and Sage, massive company. Microsoft you might have heard of, and they all have bases of operations in Dublin, and again, Dublin is a small city by international comparison. It's a city of about 1 million people in a country, Ireland, which is about 5.5, just over between 5 and 5.5 million people in the country. And you can see this is Ireland. It's a small country. You're looking at Dublin is this little area in here, and you can see the top 300 companies. So we're very well represented, and there's very good opportunities, especially for students that decide to stay back. Both of these master's programs lead to a 2-year, if you're successful in getting a master's, you're automatically entitled to a 2-year stay back visa, which allows you flexibility to apply for positions in these companies, and then they can extend those visas through skills visas, which are necessary for those roles. So the school, and both Richard and I are present in the same school. It's the School of Electronic Engineering. We've been around not us, obviously. We haven't been around in the school since 1980, but yeah, our school was established in 1980. It has 24 academic staff, and it has 6 technical support staff. So it's in a purpose-built. You can see the building down here below. It's a modern, very, very well-equipped building that has research labs and teaching rooms over on the far side, which you can't see. You're only seeing a tiny bit of the overall building. This is the Stokes building on the DCU campus. So it does mean that all of engineering is brought together into a single venue, which is great for students interacting with each other and meeting people from your classes and interacting with academics from the programs as well. So it does reflect world-class research and R&D experience in the school, and it does tie in. It provides a venue where we engage with industry as well. So it's important that we have such a venue. So the MSc program, the MSc is in Electronic and Computer Technology, and this is a full, what we call level 9. So there's level 8 is a bachelor's degree, level 9 is a master's, and a level 10 is a PhD. So it's the second highest qualification you can attain in Ireland. And so it's quite a significant award. The MSc in IoT is about being able to developing up you cover content that's relevant to the full stack of the IoT, and I'll go into that shortly and explain what the modules are. But effectively, if there's anything to do with the IoT, the Internet of Things, this program is about that. It's very much I would describe it as the intersection of the computing world and the electronics world. So people who come to this program from an engineering background probably need additional, if they've come from a traditional program, they probably need additional software skills. And people who come from a computing background probably need additional electronic skills. So it's kind of the intersection between two really large domains that are typically taught in separate streams at undergraduate level. So that's why it's an MSc, it's a Masters of Science, and that's how it's slightly distinctive from the MEng, which are very much engineering discipline subjects that Richard is going to talk about shortly. So the Internet of Things is really the next evolution of the Internet. The Internet today has moved on from the Internet of brochureware and companies selling products to being the Internet of people, where people engage through X or Facebook or whatever social media you engage with. The next generation of the Internet is seen as being the integration of the world with the Internet. So the connection of devices talking to devices. So not necessarily talking with humans, and we're not really part of that engagement. So this could be, for example, your central heating in the context of a home example, talking automatically to weather services, for example, to get the weather forecast to know how to heat the house. So the Internet of Things is very much a next generation, an evolution of the Internet, and it's an engagement with machine learning and bringing machine learning technology and bringing machine learning to the edge of the network as well, so that decisions are taken locally as part of the edge of the Internet of Things. So effectively, we describe technologies that enable the Internet to reach out to the real world, and it will affect every single sector. Typically, you see the word smart. Whenever you see the word smart present in an area like smart traffic, smart cities, smart industry 4.0, smart grids, smart home, you're typically talking about the IoT, the Internet of Things, and having a role. So you can imagine on each one of these areas, there's a massive demand for people to engage and develop connected solutions that connect sensors to the internet, that are able to develop the next generation of IoT so that we can make decisions at the edge of the network rather than sending everything centrally to the center of the internet. So that's what this program is about. It's everything to do with that, and we'll see the subjects for that shortly. So what's special about it? Well, we designed this in collaboration with industry. We worked with a SkillNet in Ireland to reach out to industry and see what did they see were the future skills that were needed. So we reached out to multiple companies and worked out what were their demands, where did they see the future going. And it's even evolved since we've originally designed the skills that we've originally introduced. We've evolved and we add new modules over time as things become more important. I would say the most important sort of novelty about this program is that it's a full stack IoT program. We cover everything from the electronics of sensing to the embedded microcontrollers at the edge to the network communication using network communication at the software and at the device level. The network communication, we deal with cloud. How do we do web application development? How do we do machine learning? We look at blockchain technology for disaggregated storage of information. We look at security for how do you secure the whole thing. And we even look at entrepreneurship for how we can actually apply these all these different concepts into a corporate environment or for you in the establishment of a new business. So it's very much a full stack program that tries to cover the end-to-end of the IoT. This has evolved from research that has taken place within the school. So we are research active. In particular, I do a lot of research on edge embedded machine learning and computer vision. And that research is applied then to my modules on connected embedded systems, for example. And similarly for the security modules and the machine learning modules and all the other modules, there are areas of research that are active within the school, and the researchers, the professors who do their research in those areas, take that knowledge and distill it and bring it into individual modules as part of the program. So that's the structure in terms of where those modules come from. We have a slightly different project structure on the MSc versus the MEng. It's more tailored to allow people to develop their own solutions, and we provide formal RD&I training as part of the project. And that's one big distinction between this program and the programs Richard is going to talk about, I would say, is that the project is better set up for people who haven't completed very significant projects before. There's more training as part of the overall project structure. We also have flexible delivery. All of the modules that are delivered on this program are screencast recorded. We use a virtual learning environment. We have physical lectures every week in these modules, but there's also, it's possible that if you miss a lecture that there will be a recording of that lecture available. So if you're part-time, if you're full-time and you missed a lecture, it's available online. If you're remote and part-time, you'll be able to follow along and watch the lecture videos every week as part of the class group as well. So it does have a flexible mode of delivery in terms of the overall structure. So this is probably the most important slide that I have to explain the program, and you'll see that this is the program structure. So you can see that in total you have to do 9 modules out of this set here. So there is some choice. You don't have to do all of these modules. And that choice can be driven by your interest, or it might be, for example, that you're coming in as a professional programmer, so you don't need to cover this OOP with embedded systems, for example. You feel you've got the prerequisite knowledge. So this set of modules is the full set of subjects that are available for you to take. So overall, you have to take 9 modules, 4 of the green set, up to 4 of the green set, and then at least 5 of this purple set here. Along with, and I'll explain the distinction in a second, and then down below, you must complete both of these elements. These are the project elements. So you can see the formal project training that I spoke about. This is a 7.5 credit module on RD&I training. It takes place in May and June. And then that follows into a project which takes place in June and August of the calendar year in which you're studying. And this is a sort of a self-directed project that you develop based on all of the content that you've covered in these modules, for example. You have a mentor assigned and you work with the mentor to develop this project solution. So there's 22.5 credits out of 90 as assigned to the project elements, and then you have to do a set of these projects. We call these supporting modules in this program, and you can do up to 4 of these. And the idea is these are late stage level 8 modules. So these are kind of like the modules that you would have covered at maybe in your final year of your degree. So you can do a maximum of 30 credits at this level. And these would cover topics like programming and mathematical techniques that you might need to refresh. For example, if you're a part-time student coming back after a break from university, you might need to improve your programming and mathematics skills. So we would strongly encourage you to take these 2 modules. They then feed into the modules that take place that follow on. These are what we call level 9 modules. These are the more the research-oriented modules. So these ones are very much structured to sort of lead the students through those modules in a very controlled way. And then these modules here, slightly more research-oriented. These are the level 9 modules that help cover the advanced content in the masters. So you can see as part of the supporting modules, we have object-oriented programming, mathematical techniques, data analysis and machine learning. This is the introductory module, which leads on to a more advanced module in the second semester there. We have wireless communication, web application development, and bioelectronics for all things wearable as part of the Internet of Things. So these are the supporting modules that help develop skills and competencies, and then they lead into the core modules that describe the Internet of Things. For example, connected embedded systems is very much about the edge of the network and developing devices that can sense and actuate in the real world. DSP for grabbing data from sensors at the edge or in a controlled environment. Data analytics and machine learning follows on and is advanced techniques for deep learning and so on as part of data analytics. Network stack implementation looks at the network and everything to do with the network communication that will be necessary for IoT. Security, obviously critically important for IoT in terms of understanding security technology techniques. Blockchain scalability for distributed databases, and then the entrepreneurship module that I mentioned as part of that sort of how do you take the skills that you've learned in these modules and then apply them in the real world in a commercial context. So that's the overall program structure. To do this, you take these modules over a full calendar year. So if you are taking this program full time and you're entering in autumn, so that would be, for example, September 2025, you would take 4 to 5 modules in the autumn semester. So that's 12 weeks between September and let's say December. You would do 4 of the modules from the set in that period, and then you would do 4/5. The reason for this is you have the choice to do 5 and then 4. Most students, though, would do 4 modules in the autumn semester and go on and do 5 modules in the spring semester. Then you complete your project elements over the May, June, July, August. And by the end of August, you've completed the program. So in 12 calendar months from September to August, you've covered all 90 credits. You've completed 9 taught modules plus the 2 project modules, and you're finished in 12 calendar months. So it's a very, I'm not going to lie to you, it's intensive, it's difficult, it's a challenging program. As I said to you, level 9 programs like these 2 master's programs are the second highest qualification you can attain in Ireland. So these are quite, you're expected to engage very strongly and work very hard during these periods, but the benefits are huge in terms of being able to achieve a master's within 12 months and then having that as a sort of a gateway to industry. So that's the September entry. It's still possible, although unlikely, to enter in January of 2025. The closing date, I think, is the 6th of December, which is today. But it is possible to start in January 2025, or more likely, January 2026. In this case, you can do the program full-time in the same period. You can do it in 12 calendar months. So you would take, for example, 4 modules in the spring semester of, let's say, 2026, cover the module, the summer project during the summer of 2026, and then complete the 4/5 modules in the autumn semester of 2026, meaning you would enter in January and complete in December. So it is possible still to apply for 2025, but the deadline is very, very tight. Just to go back one step for the autumn, for part-time students, typically part-time students complete the same program but over an extended period. So typically it's over 24 months. So typically part-time students would do 2 modules in their first semester, 2 modules to 3 modules in their second semester, maybe half the project in one summer, and then finish the project in the second summer, doing 2 to 3 modules in the following year. So it's possible to complete the same program in 12 months or 24 months part-time, and we have a limit of 4 years maximum on taking the programs in all modes of delivery. So to be eligible for the program, you must have a 2-2 on a level 8 primary degree, and it must be relevant to the degree that you're taking. So we would expect that you have covered some software, or maybe you've done a primary, some engineering degree. That's the most important thing, or some computing or some physics degree, where you've covered the mathematics that would be fundamental to engineering and computing concepts, and that you have covered some level of programming as part of that. As part of that program. Oftentimes, you might have people who've come from an electrical engineering background, and maybe they've spent a few years working in industry and they've developed computing skills, and we can take those into account as well. But the degree, the primary degree, you must have a level 2-2 or equivalent, and it must be in an honours bachelor's program. For international applicants, there's an equivalence performed when you make an application, and once you meet that equivalence, then you're accepted onto the program, and as long as you have the language requirements as well. So it is possible for applicants to the MSc and IoT program who don't have this level. If you're studying part-time, and that's important, you have to be studying part-time, you can apply for the qualifier program. So that's only available to part-time students who have who have maybe not quite met that. So that might be that you have a level 8 with a H3, or maybe a level 7 with a high award, and you've got industrial experience. So that's for part-time students only. Importantly, the part-time application and the qualifier programs, both in this program and for Richard, do not qualify for international study visa. So it's very important that you're aware that you must apply for the main program if you're applying as an international applicant. Okay. So that's really all that I want to cover as part of the presentation. I'm going to hand over to Richard in a second. I have provided the link to the program information online. You can see it in the chat. It's available here on the slides, and we might be able to make the slides available. But you can also see that my email address is there, derek.malloy@dcu.ie, and you'll see it in the chat as well. It should be. I'll just make sure it's in the chat as well. So I'm available if you want to ask me any questions as well at any stage. If you think of questions afterwards, after the talk, or if you're watching a recording of this presentation, you can ask me questions then when you get the chance. So I'm going to stop sharing now. I'm going to hand over to Richard. Richard, are you there? Yeah.
Hi, Derek.
Okay.
Thanks for
and
that.
I'm going to stop sharing.
Okay. Thanks, everybody. I'm just going to start on the MECE program, which is a sister program to the one Derek just described.
You haven't shared yet, Richard. Sorry. Richard.
Yeah, well, if you cut your video, I can do that.
Stop. Okay, I'm gone. Okay. There.
Okay. You still have there. Anyway, I'll do it the old way. Hold on. Right. So, so it's the Masters of Electronic and Computer Engineering. So it's very similar to the previous program, the Internet of Things. We do have a project in it, it's slightly more credits awarded against the project. That's basically the difference between, we have a major in Internet of Things, which is much the same as that, except we don't have that 7.5 credit precursor to your project management skills. We sort of expect that people will have done projects at level 8 and have the necessary skill set for that. So it's another 12-month program. You get a Masters of Engineering, which is, as Derek explains, a level 9 award. We have 4 majors in it. We also have a general option. So roughly we've got about 30 different modules that you can choose from. And if you just want to pick from them, we allow you to do that. And that's called the general option. Whereas some students feel that they need guidance in what subject choices to pick. So we've discussed with industry what's needed at the moment in industry, what's the flavor of the month, if you like. And we've come up with 4 different paths, as well as the general major. So we've got image processing analysis. I'll go into them in more detail later on in the slide pack. Internet of Things, as we just talked about, nanotechnology and photonics, and then the data and telecommunications networks. More information on them there. You will get the slide pack. It is a full 1-year program, so we do typically, most of our students start in September and go all the way around to the next August. As Derek explained, there is a part-time option, and that closes today if you want to start in January. Otherwise, if you miss today, it's January 2025, 26, would you believe? Yeah. And so these are the indicative entries. So for full-time, you come in September, you do 12 months. There is also a qualifier option there. So if you don't meet the requirements of H22 and a level 8 engineering computing, we sort of give you the same modules to take, but we make sure that you can pass them comfortably before moving directly on to the MEng program. So the qualifier, we usually get 1 or 2 students on that, but the majority of our students will take the MEng directly. We do have part-time options on it, so you can do it in 2 to 3 years if you're working, which is much more suitable. Full-time in January is 18 months, so it's a bit less hectic. The 1 year full-time is quite an intensive one. We wouldn't recommend anyone trying to do that while working. And then you have the part-time January. To pass any of the MEng awards, we need you to pass 8 7.5 credit modules. Of them, you can take 4 of them at level 8, which is like the ordinary degree level or higher degree level, and then 4 level 9, which is master's level. You can do all 8 level 9 if you want. Along with that, you need to pass a 30 credit project. These credits are they're European credit QQI awards, so they're interchangeable with different universities. So they're recognized all around the world, really. So it's the longest running program of its type in the country. Our graduates get very good employment. Typically, people pick up jobs before they finish the course. State of the art, as Derek explained, we try and keep up to date with the latest and greatest in the industry. So sometimes that can mean the leading edge is the bleeding edge, and it can be quite difficult to get your head around some of the concepts because there isn't a body of work there. The stuff is all changing very rapidly, as evidenced by the revolution in AI and machine learning that's currently happening. And we offer a range of flexible options. So most lectures will be recorded. Some will be streamed live. The best experience is coming on campus, but we know in the modern world, especially since the pandemic, that people are more used to online education, and so we try and accommodate you as much as we can. We talked a bit about the different companies available in Ireland. Like, for spurious reasons, a lot of people have their European headquarters here. So employment is at quite a high level in Ireland. The unemployment rate is at a record low. So that means, lucky for you guys, the salaries are quite high at the moment. We've got good ties to the Engineering Ireland. We're accredited by Engineers Ireland, and we keep in touch with all our industry partners to find out what is required out there. The structure is for the 12-month program, you start in September. In semester 1, which is 12 weeks, there will be, each module will have a 3-hour lecture every week, and we recommend you take 3 to 5 modules, depending on your workload. If you feel the appetite to do 5, that's as most as we can recommend. Typically, students do 4, and then in semester 2, they'll do another 4. But you can vary it, weighted more in the start, and then start preparing for your project earlier if you wish. Once semester 2 is finished, which is 12 weeks of teaching with a reading week in the middle, then you will move on to your project work, which is sort of self-directed, but with the supervisor. So it's up to you to arrange meetings with your supervisor. You'll do stuff like literature review and methodology, and then you'll go to the library, hopefully, and eventually get to the labs and maybe build some circuits for us. Or write some code if you're doing the IoT. We process all the results then, and you will hear your grade in November, usually of the year, and then the graduation ceremony is the following March. Compulsory attendance is not required for graduation, but it is a nice day, and if you're in the country, we really recommend that you come along, because it's a nice chance to meet up with your fellow students and reminisce about how difficult or easy the project was. So the other option on the full-time, you can start in January and do it over 18 months, in which case we recommend you do 3 or 4 modules, take the summer off, 3 or 4 modules in the next semester, finish off any remaining modules in semester 2 of the following year, and then fall in with the rest of the 12-month program, and by doing your project in the summertime. Graduation is the same, and same thing, we have to do at least 4 level 9 modules at 7.5 credits, and then either a mixture of 4, 8, level 8 or level 9, with the project taking 30. Here's a part-time of 24 months. So if you start in September, you can do 2 modules perhaps in each semester. It's up to you. So once you do the 8 modules and then move on to the project, so it's similar. And semester 1 entry, you come in September, do 2, then semester 2, do 2. This is the qualifier program, yes, I mentioned this. So this is where you don't meet the requirements. Once you've got your 4 modules and you've passed them, so you pass it's a bit quirky this, but we expect you to pass them at 40% for level 9s, but if you take level 8s, we need you to pass at 50%. Then you move into the main Eng program and continue with the other students. So we've got the general major, which is just pick any old selection of modules that you require. So you just go with what you think you're interested in. It's often easier to pick the stuff that you're interested in rather than stuff that you don't like. But so the general one is for people who just have a direction in mind. Whereas with our 4 majors, we sort of urge you towards picking certain core modules and then suggested ones on the right here. So for the IoT, Derek went through these, got the machine learning in there. And then if you're doing machine learning 2, we'll expect you to do the machine learning 1. So that's machine learning is very mathematical. It's not not so much like programming, as much more statistics and maths and curve matching and stuff. It's not exactly what you might expect, so just be wary of that. The network stuff and all that, Derek explained it, and security for IoT. So with IoT devices, because they're small and not like a big PC that we'd have nowadays with all the full software stack in it, your software stack might be minimized, so you've got to worry about hackers being able to get access to these systems that are out in the field. They're not protected by firewalls and such. So security is a big thing when it comes to systems and IoT. We have the nanotechnology and photonics, which is much more traditional electronic engineering, where you get into the physics of how devices work, pushing the boundaries of what materials are available to get like transceivers that will work at speeds that the internet require now. So optical technology has come on, and I see NVIDIA now are looking for optical connectivity between their processors, because the power required for copper connectivity for the bandwidths they're talking about, it's just hitting a limit. So they're thinking of moving to optical. So optical in a computer is quite pushing the boundaries of technology, but that's where it's all going at the moment. The whole Bitcoin craze caused all GPUs to be diverted from gaming machines to data centers, and then that infrastructure was then adapted with the machine learning revolution. So everybody's using the GPUs for them, much to the chagrin of the gamers out there. So you'll do stuff like photonics, bioelectronics, which is similar to the Internet of Things, stuff like energy system decarbonization, and solid-state electronics and semiconductor devices. So going back to your level 1, level 2 engineering, and if you come from a computing background, this will all be new to you, but it will hold your hand and get you through it.
Sorry about that, folks. We seem just to have lost Richard there for a second. We're just going to try and touch base with him offline. Oh, hold on. Sorry, Derek, you're just muted there. I'm not sure if you're trying to talk.
I'll take over for a minute there, Martin, just to try and keep it going until he comes back again. So I think he was working on the major in data and telecommunication networks, and he talked about some of the modules that were available there. So I suppose just to fill in on the project piece, as I said earlier when I was talking about the MCTY program, a big distinction between the MCTY and the MECE is the project, and this is a big body of work that takes place on the MECE program. It's a 30 credit project that takes place over the full year. So compared to the MCTY program, where that's over 3 months and it's spread into training and a project, the majority of the work still happens over the summer, but there are milestone deadlines all the way through the full calendar year, as you can see here, from literature presentation, oral presentations, and project design plans, right through to the sort of main body of work which takes place during the summer months. So again, it's expected, I suppose, in both projects that you have something that's very much at the leading edge, that's potentially publishable in the case of MECE. I would think that in the case of MCTY, it's more about a business, technical business plan. MECE, it's that you would be able to publish the work at an academic conference, for example. So that's a big distinction between the two programs, and that's important to MECE. The entry requirements, I don't need to go through them really, as they're very similar. There isn't much difference at all. You have to have a H22 in a relevant degree. I suppose MCTY is slightly more computer oriented. MECE, which is a Master of Engineering, you're expected to have a very strong, sort of a more aligned engineering background as part of the entry. There's also a qualifier program into MECE. Again, this is not eligible for international visas, but it is available, especially for part-time students who don't meet the entry requirements, or for part-time for full-time EU students who don't meet the entry requirements. So this might be, for example, someone who's just left a level 7 or level 8 undergraduate degree and wants to go on to do a master's. We have a route, and we can Richard will follow up if there's any questions on that. The program fees are actually the same for both programs. There's an EU fee is €7,500. The non-EU fee is €25,000. But I would just keep in mind that there is the opportunity for scholarship against that. There is an individual fee assessment that's performed for everybody who applies to the program. And depending on your academic qualifications, it's possible that there will be a reduction in the fee, a scholarship reduction in the fee applied by DCU Global. So you can follow up on that if you're interested in the fees, or follow up with Richard or myself on that. As Richard said, probably the next deadline that's probably most important for people is the 1st of July 2025 for non-EU, and the 20th of August 2025 for EU. Shouldn't be 25. There is a January entry, but that's the 6th of December. That's today. So if you haven't already begun an application, it would be very hard to meet the documentation requirements by that deadline. There are links then, as there are in the chat, to the programs. And Richard's address, I've also put it into the chat there as well, Richard's email address and the link to the program. I've made them available in the chat too. So if you have any questions, please feel free to contact either of us at those two addresses, or by connecting to the program information. And just to finish off there with a slide, there's some pictures of the Glasnevin campus, which is one of several campuses that are present in DCU. Most of the engineering work and pretty much all of the modules you take, you might do some examinations or attend some social events on other campuses, but all of your lectures and all of your engagement would be on the DCU Glasnevin campus, the main campus. So it looks like this, plenty of green, lovely green space. There's student accommodation. That's an example of lecture rooms. That's the library. There are some older buildings that have been around. That's our sports facilities and the green space outside. So that's all I really have to talk with you about today. So I'm going to finish it now. I hope I've answered that we've answered most of your questions. Sorry that Richard had a connection problem there and dropped out, but he will be able to follow up with any questions online if you have them afterwards. And I'm available to answer questions now as well if needed.
Thank you very much for that, Derek. Folks, we do apologise. Richard just was experiencing some technical difficulties, but thankfully Derek was able to step in and complete the presentation. So folks, if you do have any questions, please do type them into the chat now. If there aren't any questions, we will finish up the session for today. In the meantime, just in case anyone is typing, I'd like to thank, obviously, Derek and Richard for giving us their time today to present on these programs. They've been very informative and comprehensive presentations. I think I'd be surprised if there was too many questions after that, Derek. They were very, very comprehensive and covered basically all there is to do with the course. So thank you so much for that.
Thanks, Martin. Yeah. Look. As I said, I think if there are questions, they can follow up by email at the two addresses in the chat. We're able to answer questions at any stage. So again, there's a lot of information to take in there. Maybe too much information for the time, but please follow up if you have any questions.
Great, thank you for that, Derek. I think we'll wrap it up there, folks. I don't see anybody typing away. So listen, thanks again for tuning in. Thank you for joining this webinar week session. And Richard and Derek's email addresses are there. In the meantime, thank you very much, everyone. Have a lovely afternoon, evening, morning, wherever you're tuning in from across the world. And have a lovely weekend as well. Thanks.